Alrighty then. So to this video or this lecture, we're going to talk about the ratio and root test. Well, actually, we're just going to talk about one of those, and those are the last tests that we're going to talk about that we can use to determine if a series converges. Again, these tests do not give the value of the series. So the first test is the ratio test. And sort of here's how it goes. Oh, here we go. So let's suppose, like we always do, that we have an infinite series, summation of a sub n. So that is an infinite series. And we're going to define R as the limit as n goes to infinity of the absolute value of the n plus first term divided by the nth term. Then here we go. If R is greater than or equal to 0 or less than 1, then the series converges. If R is larger than 1, then the series diverges. And last but not least, if that number R is equal to 1, then the test is inconclusive, which means what? Well, it means we don't know anything using that test, and we have to use another test. So in this case, if it's inconclusive, we would need to apply another test. All right, well, that's kind of all there is to it. Let's just do some examples then, shall we? Dun, dun. All right, so we want to use the ratio test to determine if the series converge. All right, so a sub n is literally what you're summing, and it doesn't matter where the series starts. And so the n plus first term, right, we replace n by n plus 1. So I have negative 1 to the n plus 1, 2 to the n plus 1 over 2 times n plus 1 factorial. So we might want to simplify this real quick. Well, maybe simplify is the wrong word, but this is 2n plus 2 factorial. Let me just scoot this over because it's kind of smushed there at the bottom. All right, great, wonderful, super, woohoo. All right, notice a couple things. First of all, 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n times 2n minus 1 times 2 times 1. And we can, hopefully you could see that this part is equal to n factorial. So we see that 2n plus 2 factorial is 2n plus 2 times 2n plus 1. I don't know why I wrote n factorial. You know what I meant to write? That was supposed to be a 2n factorial. Wow, I can't read my writing still. I hope you guys are getting better at it. All right. So also, so that's one note, and the second note is 2 to the n plus 1 is 2 times 2 to the n. All right, so r is going to be the limit as n goes to infinity of the absolute value of the n plus first term divided by the nth term. But, you can write this as, the absolute value of one divided by the absolute value of the other. All right, so let's plug and play. Mommy, I don't think I gave myself enough room. In fact, I'm pretty sure I didn't give myself enough room. Oh boy. All right, well, let's see if we can scooch it in. So we're going to get the limit as n goes to infinity of the absolute value of negative 1 to the n plus 1, 2 to the n plus 1 over 2n plus 2 factorial divided by negative 1 to the n, 2 to the n over 2n factorial. So the absolute value just knocks out the negative n plus 1s. And I'm going to get 2 to the n plus 1 over 2n plus 2 factorial times 2n factorial over 2 to the n. Right, so again, the absolute value, the only thing that's not positive is just the negative ones. All right. We're doing verticals today, no horizontals. All right, so now what do we have? We have the limit as n goes to infinity of 2 times 2 to the n over 2n plus 2, 2n plus 1, 2n factorial times 2n factorial over 2 to the n, and stuff's going to cancel, and the 1, and the 2. So we're looking at the limit as n goes to infinity of 2 over 2n plus 2 times 2n plus 1, which is 0. So since r is equal to 0, which is less than 1, the series converges. Phew. I feel like saving that. Okay, so again, take a look through this, pause if you have questions and write them down so you can ask them in class, super important. All right, let's do another fine example brought to you by, I have no idea because I can't remember where the source of these examples problems were, but let's do some more. All right, so we have 3 to the k over k squared. All right, so ak is 3 to the k over k squared, so the k plus first term is going to be 3 to the k plus 1 over k plus 1 quantity squared. All right, so r is going to be the limit as k goes to infinity of the absolute value of ak plus 1 over ak. So we have the limit as k goes to infinity of the absolute value of 3 to the k plus 1 over k plus 1 squared divided by the absolute value of 3 to the k over k squared. Both of those are nice and positive quantities, so everybody's positive, but just to keep it detailed for you, we get this. So r is going to be the limit then as k goes to infinity of 3 to the k plus 1 over k plus 1 quantity squared times k squared over 3 to the k. We already talked about that this is equal this, because you know what's in my head. We talked about that this is equal to It's hide and seek. 3 times 3 to the k. And so we can cancel out the 3 to the k's. Bye-bye. See ya. And so we're looking at the limit as k goes to infinity of 3k squared over k plus 1 squared. So we can write this as 3 times the limit as k goes to infinity of k over k plus 1. My brain and the pen are not playing well together. All right, come on, come on, come on. Oh, for Pete's sake. Right, we could put everybody under 1 square root. And you know how we always divide the numerator and the denominator. Oopsie. Divide by k. Divide by k inside the square root. We can write this as 3 times the limit as k goes to infinity of 1 over 1 plus 1 over k squared, which is just going to give us 3 times 1, which is 3, which is bigger than 1. So since r is larger than 1, that tells me that the series diverges. So we have a divergent series this time. So again, you should look at look it over, make sure you understand, don't have any questions. Since I'm recording and we don't want to waste the recording time for that, I'm going to move on to the next example. Ooh, that looks fun, doesn't it? Okay, so a sub n here is -1 to the n minus 1 times 3 to the n over n factorial times n. So the n plus first term is going to be -1, and plus 1 minus 1 is n, n plus 1, n plus 1 factorial, n plus 1. Right, so again, recall that n plus 1 factorial is going to be n plus 1 times n factorial. Just sort of let's keep that off on the side in our, that was, boy, did that go off to the side. Don't know where that went. Will we ever find it? All right, so r is going to be the limit as n goes to infinity of n plus first term divided by the nth term. So we have the limit as n goes to infinity, absolute value of -1 to the n, 3 to the n plus 1, n plus 1 factorial, n plus 1, over absolute value of -1 to the n, 3 to the n, n factorial n. When we take the absolute value, everything is positive except -1 to the n, and the absolute value of -1 is 1. So again, that just goes away. All right, so we get the limit as n goes to infinity of 3 to the n plus 1 over n plus 1 factorial times n plus 1 times n factorial times n over 3 to the n. So as a reminder, right, this is 3 to the n times 3. This is n plus 1 times n factorial. So what's going to happen is some good stuff is going to cancel. This guy cancels with this guy. This one cancels with this one. And we're going to be left looking at the limit as n goes to infinity of 3n over n plus 1 times n plus 1, which I think we can just go as 0 because the denominator has a higher degree than the numerator. You could prove this by dividing everybody by n, but that's starting to be a pain. So we know it's 0. So since r is equal to 0, which is less than 1, that tells us that the series converges. Awesome. Let's see if we can sneak in one more example, and then I will put up an exercise, but I'm going to leave you in suspense on the exercise till the next video. So you have the exercise, and I'll give you the answer, but you should really work on it before you watch the next video. I'm sneaky, huh? Okay, so let's do this one, and then I'm gonna probably call it a video because it's painful. The kth term is k over k plus 1. So the k plus first term is k over k plus 1 over k plus 1 plus 1, which is k plus 1 over k plus 2. So r is going to be the limit as k goes to infinity of absolute value of k plus first term over the absolute value of the kth term. Okay, everything's positive, so I don't have to worry about the absolute value here. So I'm looking at the limit as k goes to infinity of k plus 1 over k plus 2 times k plus 1 over k. So I have the limit as k goes to infinity of k squared plus 2k plus 1 divided by k squared plus 2k. And what is that limit? So again, if you're bored, divide through numerator and denominator by k squared. So we have the limit as k goes to infinity of 1 plus 2 over k plus 1 over k squared divided by 1 plus 2 over k, which is 1. So here's the thing. Since r is equal to 1, the ratio test is inconclusive. So we would need, we sure would, to use another convergence test. To find the convergence of this series, or to determine if it converges. To determine the convergence of this series. Boy, is this a long video, sorry. Determine the convergence of this series. So what might be a choice? I would use the divergence test. Why? Because if you look, the limit as k goes to infinity of the kth term is going to give me 1, which is not 0, so the series diverges. I feel like this has been a really long video, for which I strongly apologize. And so what you should do after you watch the video is see if you could do this exercise. Now, in case you are in anticipation, the answer is yes, but that will be the next video. On the next video, we'll do this, and then we will discuss the root